Hey, this is Mr. Ward, and I'm going to do some fancier reflections. These are rigid body transformations. They change their position and their orientation. They get a mirror reflection of some sort. However, they retain all of their angles and side links, and so they are considered rigid body transformations, and they make congruent shapes, which means they have all the same angle and all the same side length measurements. And in corresponding position. So here we go. We've got our object, which has vertices at 2, -4. It's got 5, 1, and it's got 10, -2. And what we're going to do is we are going to reflect this over this line, y equals x. This is a line that has basically got every single point on this line follows one rule. X equals y. Whatever x is, y equals the same thing. So I can drag, this is a thing you can do on Desmos, I can drag my cursor along the line, and no matter what point I find, the x value equals the y value. Okay, well, in order to reflect across this, here's all I have to do. The x and y values have to swap positions. If I swap the x and y value positions, I will reflect across that line. So let's do that. And there we have our new reflection across x, y. So 5, 1 became 1, 5. And then 2, -4 became -4, 2. The x's and the y's have just changed positions. 10, -2 became -2, 10. Cool. Now let's take a look at what happens if we were to use the line that follows the rule y equals the opposite of x. So every point on this line, y will be the opposite of what x is. So make that line. There it is. As I drag my cursor on here, you can see every x value is the opposite of every y value on this line. That is the rule of this line. Okay. Now, if I flipped this one, not only am I going to switch positions for x and y, I'm switching the signs for x and y as well. So what's going to happen is 5, 1 is going to become not 1, 5, but -1, -5. So, and same with this one. It's going to become 4, -2. The -4 and the 2 are going to swap positions and change signs. And of course, likewise with 10, -2. So let's see what happens. And there we go. I have flipped across, I've reflected across the line y equals -x. And that's all you have to do in order to make those reflections. So I'm going to put a little note here. So to recap, flipping across, or reflection of the object across y equals x, swap the x and y coordinates for all points. And that's all you have to do for that. For this one, reflecting across y equals -x, we swap the x and y coordinates for all points and change the signs for all of the new coordinates, okay, x and y. So x, y becomes -y, comma, -x. And that becomes your new coordinate. Up here, x, y becomes just y, x, like that. You switch the signs. And I hope that was helpful for you for those. Now I'm going to go ahead and turn my various lines and reflections off for right now. and we're going to explore some other ones. Okay, so we're going to continue using our original image here. Okay, and I'm going to go ahead and do a little setup here behind the scene. Now what we're going to do now is we're going to try reflecting the object, make an image that's a reflection of the object across the line y equals -3. So what is a line y equals -3? Well, it's a horizontal line where every single point, if I drag along here, no matter what my x value is, my y value is always -3. And so what I'm going to do is I'm going to take this triangle, I'm going to reflect it across that. So you could intuitively expect this point here to be on the other side of it, this point here on the other side of it, and this point on the other side. Now, but how do we mathematically work all of that out? Well, what you need to do is we're going to change, well, the x coordinates are going to stay the same because horizontally there's no change. It's vertically what the change is. So we're going to change the y coordinates. Now, how much are we going to change the y coordinates? Okay, what you're going to need to do is you're going to take the y value and you need to find out how far it is from -3. So that's just going to be the y value. So like here, -4 minus -3. -4 is 1 away from -3, but it's 1 below. And then you're going to subtract twice that difference. Let me show you what that looks like. I'm going to do the same thing with this one. -2 is 1 above, so you're going to subtract twice that distance, which will end up being 2 times 1. You'll end up down here at -4, because that's what -2 minus 2 times 1 is going to be. And this one here, you're going to subtract, you're going to find out what is the difference between 1 and -3. It's going to be 4. You're going to subtract, and so we're 4 away from this line. So we're going to subtract 2 times 4 from 1, and we'll end up down here 8 below, which will be at -7. Let's actually just work that out, though. So this is my original triangle, and I'm going to go through each of the y values. The x values are going to stay the same. And what I need to do is I'm going to subtract 2 times, and I can do this within a point to calculate, 2 times the difference of -4 and -3. Why -3? Because the line is y equals -3. Why -4? Because -4 is my original y value. So 2 times -4 minus -3. Okay. And you'll see a point has just popped up that's just right on the other side. Now let's do the same thing to the next y value. That's going to be minus double the difference of that y value, 1, and -3, 1 minus -3. And you'll see that this point is popped up on the opposite side of this line. 1 to this one. So that's going to be 10 minus 2 times 10 minus, that's not a 10, 10 minus -3. And I have done a goof. Let's sing on. I made a mistake. I grabbed the x value. So let's fix that. I wanted the -2. I wanted the y value. So minus 2 times -2, because that's the y value, minus -3, because that's the y value at the line. And to make this triangle really work, I have to go on and do it for the last one. So minus 2 times -4 minus -3. Okay, so I've got all of that stuff. I'm going to go ahead and give it lines. And then we're going to tidy this up because this is kind of a pretty ugly set of points. Okay, so I've got all of that stuff. Let's actually work out what these are. So let's first deal with what's in these parentheses. -4 minus -3 is -1. So I'm going to be doing -4 minus -2, sorry, minus 2 times -1, so that's going to be minus -2. Okay, and so 4 minus -2 is going to be -2. And that is exactly where I wanted to be. Over here, I'll do 1 minus negative 3, which will be 4. So now I'm going to be doing minus 2 times 4, so minus 8. And then 1 minus 8 will be negative 7. And then I'm going to zoom in just a little bit on this. A little nicer to see. And I'll clean up this one. Negative 2 minus negative 3 is going to be positive 1. So I'm going to be subtracting 2 here. And negative 2 minus 2 will be negative 4. And then finally, we'll clean up the last one. Negative 4 minus negative 3 is negative 1. 2 times negative 1 is going to be negative 2. Negative 4 minus negative 2 will be negative 2. And there we have a nice reflection. You can see it visually, that is pretty clear reflection across y equals negative 3. I'll plot the points and identify the points here as well. And you can see they have all kept their x values. So their horizontal position didn't change, but their y values changed by twice the distance they had from y equals 3. I'm going to turn those off now and go ahead and deal with the other question, which is what happens if we reflect this across x equals 8, which is a vertical line right here. Okay, so we're going to use a similar approach. In this case, we're going to be dealing with the x distance. Okay, so we'll take the x value, we'll subtract 8, and we'll double that. Okay, and then that's what we will subtract from our original x point. So let's go ahead and grab this. So Control A, Control C, and then Control V. Okay, and what I'm going to do is I'm going to systematically go through all of my x values. So I'm going to subtract twice the difference of my x value here, which is 2, minus 8. Okay, that's going to get me my new x value. And I'm going to actually zoom out just a hair so you can see that this point here became this point here. Negative, so on the y values stay the same. So I forgot to mention that. The y values are going to stay the same. So the x value, so this 2 is 6 away from 8, as is 14 on the other side. 14 is also 6 away from 8. So it preserved the distance, just flipped it over on the other side. Okay, so let's go ahead and continue that process. So I'm going to subtract twice the difference of 5 and 8. Okay, and so this point here is at 11,1 versus this point here, which is 5,1. Okay, both of those are 3 away from x equals 8. 5 is 3 less, 11 is 3 more. The y value stayed the same because we're only doing a horizontal reflection here. Okay, once again, we'll deal with the 10. So minus twice the difference of 10 and 8. Okay, and so now that point, starting here with 10, negative 2, we're going to end up, so 10 is 2 away, so we'll end up with something 2 away on the other side. Okay, and so we'll end up with 6, negative 2. And we have all of the points we need except for the last bit where we need to make it loop around. So this is just for Desmos purposes. Minus 2 times 2 minus 8. Okay, now I'm going to go ahead and myself a little space to do this. I'm going to go ahead and put lines around it. There we go. Now, let's clean that up because that's a mess. Okay, so each one of these things, we actually want to know what the point is. So let's deal with what's 2 minus 8. That's negative 6. And so I'm going to be doing 2 times negative 6. That'll be negative 12. Okay, and 2 minus negative 12 is going to be 10. No, I'm sorry. is going to be 14. 2 minus negative 12. I will add 12 to 2, so that's going to be 14. Now over here, I'm going to be dealing with 5 minus 8, which will be negative 3. I'll do 2 times negative 3, which will be negative 6. 5 minus negative 6 is going to be 11. And then I will deal with 10 minus 8 here, so that's going to be a 2. And 2 times 2 will be 4. And so I'm just going to do 10 minus 4, which will be 6. The last one, I will do 2 minus 8, which is negative 6 again. And so that's going to be negative 12. And 2 minus negative 12 is going to be 14. And there we have our reflection across x equals 8. So to recap, in order to find the points for, let's say, this is going to be a vertical transformation, a vertical reflection, okay? In order to find the points, what you need to do is subtract 2 times the difference of your object's y coordinates from the horizontal lines y value. Okay? And that will allow you to find the new points. Okay? Each new point will preserve the horizontal x position, coordinate I should say, but will be the same distance. Let me say, on the opposite side of the horizontal line vertically and the same distance from it. So basically vertically the same distance, just on the opposite side. Okay, and if we're dealing with going across a vertical line, we're going to do basically the same thing. We're going to, let me actually just grab this and I will simply edit it where appropriate. Okay, so instead of 2 times the difference of my object's y coordinate, now it's going to be the x coordinate. And it's not a horizontal line, it's a vertical one. Okay, and it's the vertical line's x value in this case. So each new point will preserve the vertical coordinate, or y coordinate, but will be on the opposite side of this vertical line horizontally. We're just swapping it all out. And the same distance from it on the opposite side of it. So in this case, we took this point, which is 3 away from x equals 8, and we kept the y value, and we ended up 3 away from x equals 8 on the other side horizontally. Okay, this blue point is 2 to the right of x equals 8, and so we ended up 2 to the left. Same vertical position. This point is 6 to the left, we ended up 6 to the right, keeping the same vertical position. All right, I hope that was helpful for you.